नमस्कार दोस्तों। आज की इस वीडियो में आपका स्वागत है। आज हम अर्बन फ्लडिंग पे बात करेंगे और हम उसको जो है हैकरास से मॉडल करेंगे और मॉडलिंग में हमने क्या क्या करना है और क्या क्या हमें सीखना है वो सब हम इस वीडियो में सीखेंगे। सबसे पहले आज तक हमने जो सीखा और आज जो कुछ भी हम करने जा रहे हैं वो उसी पे बेस्ड है। हमने हैकरास में 2D मॉडलिंग सीखी। हैकरास में 2D मॉडलिंग में हम कैसे जो है प्रेसिपिटेशन या रेनफॉल को मतलब रेन ऑन ग्रिड कैसे हम बना सकते हैं, रेन ऑन ग्रिड कैसे एनालिसिस कर सकते हैं और हमने जो है रेन ऑन ग्रिड सीखा प्रॉपरली। अब हम लाइक by learning this rain on grid modeling, we can understand, yeah, we can got to know कि if precipitation or rainfall takes place at any place or on the earth, we can model that, we can understand that if this much of rainfall takes place in this area, then this much inundation will be takes place in these locations. So we can do that till now. Okay, but this is for those areas where manholes are not there, civil lines are not there, stormwater drainage are not there. If we are talking about urban area, these things lying in those areas, in urban areas. But in agriculture areas, there you can't find like a drainage network and all those things. So at that place, till now, what we learn, we can apply at those locations. But in urban areas, there are imperviousness is more, but when runoff takes place or when precipitation takes place, if there were no any stormwater drainage system, then too much inundation will take place in the societies, in the railway tracks, in the roadways. Stormwater drainage network is very important for a urban area. My point is, for this video, we can do here rain on grid for an urban area or any area. Like here, I am going to give you of rain on grid and pipe or drainage system with drainage system. If rainfall takes place in an urban area or in a area, then how much inundation will take place, and if we provide some this pipe network or a storm water drainage system, then how we can mitigate this flooding scenario for those areas. Okay, for those areas, like this is HEC RAS 7.0. Before 6.7, you will not find this feature in the HEC RAS, but currently in 6.7, after 6.7, it start the pipe or stormwater network. You can HEC RAS allows you to model the urban system with stormwater network as well. In 7.0, it is more convenient and more flexible to use that pipe network here. So here I am going to tell you uh, uh, like uh, how you can apply this drainage network, and you will find the impact of drainage network in the inundation mitigation. Okay, let's open the project as we are working in this project, and here let me show you. Actually, I have created this model, and here I will explain you the things step by step. Okay, so how I'm going to explain you the things is here. Okay, so this is our RAS mapper, and if you are new in this video, you can subscribe this video, subscribe this channel. And if you don't have understanding about 2D modeling and how we have to set up this 2D model, how we can do this analysis, like basic, if you want to learn, you have to go to my channel, and you can you will get the videos related to that. You will understand the things, and here I am going to explain you. Previously, I have created this 2D rain on grid system. Like here you can see that if in this area if rainfall will takes place, so this type of inundation will take places for different areas. And this is a road. Let me show you in the Google map as well. Here I'm like creating this enabling this Google hybrid imagery. Here you can see that this is the road. Okay, this is the road. So you will find that less like at the road there will be no flooding, but besides the road, along the road there is a flooding. Okay, approx 3.3.5.2 meter depth have been inundated here. Okay. So this scenario you can see this maybe happen in any area. It If you are modeling for urban area, it will also you can see the inundation in roads and every places. Here I'm just taking an example, and as we started our videos through this area, this is our study area. So I'm doing that stormwater drainage system going to apply here, and we will see the impact, and we will see the things how like a stormwater drainage system we can apply in the model, and we will how we can simulate the things. Okay, so here you can see that this is basic rain on grid modeling. Okay, in this rain on grid modeling, I have applied everything like infiltration, curve number, and everything I have applied in this model. And at a particular precipitation, I got that this much of inundation at these places. Okay, so after that, here you are seeing like there is a sufficient amount of inundation takes place at both side of the road. So if you want to carry this inundation, and you want to create a drainage system for this area, like if you want to create some house here and only other things you want to you want to plan something here, and you know that this much of rainfall takes place at these places, and you want to you don't want this much inundation at this place, then you have to make a like a drainage system uh, like clear this water from here to like you can dump this water to the river by creating a drainage system. Then you can create structures or anything here. Okay, so what I did to create the inundation, like to create the drainage system here, let's go to the geometry. Here I have created this geometry, I have created 2D rainfall pipe network. Like previously we have this geometry 2D rainfall, and in that I have added pipe. So pipe network I have added. So that's why I have given its name 2D rainfall pipe. Okay, let's open the area. This is our mesh. This is our mesh and perimeter whole area. This the perimeter of the study area, and in this. The boundary condition is we have to apply boundary condition of those places where water can go. So I have given normal depth at the boundary condition at the at the downmost downward downstream of this river. Okay, and now the main thing which I'm going to explain here, if you want to do pipe networking here, like you want to do storm water uh, uh, carrier system or network you want to build here, then you have to right click here, you have to go edit, and as you click on edit you will find somewhere here pipe network. Before 6.7 you HEC RAS you will not find this, but in later version like in 7 you will find this here, and you have to check here. As you check here you can expand it, you will find two things: nodes and conduits. Okay, nodes and conduits you will find here, and in nodes you will find two things. top inlet, side inlet. Okay, what is this? You have to first think about drainage system. Okay, so in drainage system, if we search about uh, uh, let me search about road drainage system manholes. Okay, so you have seen this type of structures at many places. Okay, this type, this is called sideway. Okay, this is called sideway, but this is called from the top. Here are there are two options, you can see top inlet and side inlet. Okay, so what the difference between this side inlet and top inlet? This is top inlet, top inlet. Okay, side inlet. Okay, side inlet. Side inlet means the side inlet. Inside inlet, the drainage, like the elevation of inlet is a little bit about above. Okay, and here you can see this is the difference between side inlet and top inlet. Okay, now what you have to do? First, you have to do nodes. You have to create nodes. Okay, nodes. So when you click on nodes, you have to go here, and here you will find something. What you will find here? Here this is start, junction, culvert opening, external, closed, error. Okay, the main thing I am going to explain you, like this is the start means if at your node, like you have to click like you want to uh, create a manhole here, and after that you have to join all the manholes by the conduct, by the pipes, and after that you have to extract that pipe, and you have to dump that water so at any point or somewhere you have to dump that. So the difference between all those things is at every inlet, that is start, from where water is coming, that is start, from where water is coming, that is start, at where water meets at a junction, at that node is in the color of this color, brown color. Okay, and where you are dumping at the last, that is culvert opening. Okay, similarly, if somewhere you are not going to dump you at that point, that is closed. If you are not allow, or if you not allocate, like this uh, node is not a junction, not a culvert opening, then that node it will be treated as closed. So you have to if that node is within the earth surface, its invert elevation, its elevation is lower than that level, that elevation of dm, then that will treat as close. Okay, and if there is any error, that node will show by the red color. Okay, so here what I have did is, let me show you. Okay, so here what I have did, I have given this node here, this node, and here third node. Okay, so the idea is, first I have created this node. I have clicked here, then here, then here, here, and here. Okay, the idea is I want to take water from here to this location, here to this location, then this water will go towards here. This is the main channel, this is main not channel, this is main pipe network. And from this water I want to, if you understand, this is your home. So from your home the whole water is coming to this drain, from whole home this water is coming to this drain. So and ultimately it will go towards this direction. From this area the water will come. So you can make more grid here. You can make more grid here. You have to ultimately connect to this main grid, the main network. Okay, after that it goes here, and it has one node here, one manhole is here. It will also take water from here and it will dump to the river. This is the river where I have to dump the channel, the dump this network. Okay, and you have to make sure when you have given all the nodes, after giving all the nodes, you have to uh, stop it and save it, and after that you have to go on conduit. Okay, on after going on conduit you have to start edit, and after starting edit you have to start from one node to the junction, and you have to double click here. Okay, and from this again you have to start from this node to this junction. Okay, you have to tell it flow path. Like if you are coming from this direction to this direction, model will understand water will come from this way to this way. And if you start from here to here, model will understand water is coming from here to here. No, you have to start from here to here. If you want to take your water from here to here junction, then you have to click first here, then you have to double click here at the junction. Then the water come from here and it will meet to at a junction, and it will go towards here. Similarly, you have to like first click here and double click here, and after that you have to click first click here, double click here, first click here, double click here, and similarly you have to make this junction. And after saving and everything, okay, you have saved everything and you have created this junction and this network. Okay, after that you have to go in open attribute section. Okay, here you have to go in attribute section. So in this attribute section you have to think about. Okay, so here you will see this is the attribute of nodes. Okay, in this you will find this these columns, and here you will find the errors. Here I have done the things, but you will find error. You will find this much. This one will be like this column, this column, this column. These the columns which are not completely white. It is filled, but these things you have to fill. Okay. So how and what is the procedure to do this? So let me explain you one by one thing. Like this is uh, what this is terrain elevation means, where when you clicked for the nodes. So these are the elevation of those points where you clicked for the nodes. For node 1, which one is node 1? If you click here, let me click here, click here. Okay, like node 3, this one is node 3. Okay, similar this one is node 4. Okay, node 5. Okay, so these are the nodes and these are its elevation, uh, terrain elevation. Okay, so you have to give invert elevation. First you have to give invert elevation. Here I have given like 69, this is 65, 4 meter. Okay, 4 meter down I have invert elevation means like this is elevation of top surface, ground elevation, and the bottom elevation you have to give. Like you want to go you have to go to create a manhole type structure where water will go in the barrel, and it will go through the pipe and it will dump somewhere. So you have to dig the trench for particular depth, and you have to place your pipes in the trench. So for that you have to dig till this much elevation. So this is invert elevation of each node. Okay, and this is base area. What is base area? Base area is that location from where the water will go to this pipes, like manholes. This is the area of my area of uh, area of what? Area of manholes, like this whole area, this area, this is the area. Okay. And after that you will find like depth you have given 4 meter, and which type of inlet you are giving to the model. Like here I have given manhole standard. Okay, so there are like great curve inlet and other things you can find. You can apply anyone on the basis of your requirement and everything. Here I have I'm going to just deliver you a trial video, so I have selected for each node like manhole standard, and top elevation like where this manhole is located is at this location. Okay, at this location these manholes are located, so I have given the uh, same elevation to the manhole locations. Okay, depth, here you will find zero depth. Okay, here you will find base area zero. Here why I have given 0 here and 0 here and nothing is here in top inlet? Because this is culvert opening, this is culvert opening, this is culvert opening, means this last one node 11 is our outfall. So in outfall we have to give culvert opening. We don't need to give base area because it will dump the water. Like here that node is not receiving any water, that node is giving the water, like it is spilling the water from itself. So that is culvert. And other one the start where these are the inlets and these are the junctions. Okay, these are the junctions. At junction itself there is manhole, and it is receiving water from the start, and it gives water to the next uh, network. Okay, so that's it for this node attribute, and after that you have to save, click here and do the for the process. And next you have to go here top inlet, like you are going to give top inlet. So you have to go attribute of this top inlet. You will find these things here, and where you have to give wear length coefficient or fish area or fish coefficient such as here. What is this? This is nothing. This is like you are applying a circular pipe in the system. So like this circular pipe you are applying in the system. So circular manhole you have to give there. And uh, what will be length of that manhole, like pi r, like what is the this length, like 2 pi r, yeah, pi d. So this is pi d, nothing much, pi into d, dia of what, dia of your conduct, and pi r, this is wear length. Wear coefficient you will find from the manual, from the He-Ras manual. And this is orifice area. This is nothing, 45 to 50% of the area of base area. Like this is manhole, this is manhole area, this is manhole. There will be area which I have applied in node attribute 1.13, and which 45% or 50% we will give orifice area, means opening area to the which takes water from surface to the pipe. Okay, that's it for here. You have to apply all these things, and after that you have to go in conduct section, and here you have to open the attribute of conduct. You will find all those things here. These things are filled automatically. This length is filled. Mesh cell length, first you have to fill mesh cell length. So like pi flow is 1d flow. So you have to give a length, uh, uh, the length should be uh, that much um, like in pipe, if you give length it will like if you give 1 meter 2 meter, so all the total length, like this total length is divided into 2 by 47 by 48 by 2, like 24, in 24 segments. This length is divided into 24 segments if you give here two cell length. Okay, so in 24 segment the model will run for each segment. So for that you have to give very refined computational interval and other things. The model will become very hard and very sophisticated. You have to give low, very low or very small computational interval. That's why otherwise model will become unstable and numerically unstable. This is the meaning of this mesh cell length. So accordingly you have to choose this mesh cell length, from 5 to 10 you can give. Okay, and the shape in this version there is choice of shape selection of your conduits. So all conduits I have selected circular type. You can select other type. Here are lots of shapes are available. On that basis you have to give rise and span. If you give rise and span same, it means it is circular, uh, rise means this thing, and uh, this means this thing. Okay, so you have to give this rise and span, and after giving this thing you will give the shape or size of the culvert, and you have to give minings as well, and after that you have to save the things. Okay, after saving the things you have to run the model, and when you run the model you will get uh, like uh, uh, I will show you. This is the flow from uh, okay, well, let me save it first. Okay, okay, so this is the depth, and this is the depth here. So here now it is checked on rain pipe. So this is the depth when pipe is allocated here. Okay, everything is allocated here, and this is the depth. You can see the depth is more, depth is more, and area, inundated area is also more when this pipe is not allocated here in this one. Okay, in this one you will find. Okay, you will see the difference. Okay, so pipe is working here. It is transferring water from here to the river. Okay, and how you can see the flow in the pipe. You can you can check depth in the pipe. Here I'm zooming it, and I'm starting the uh, animation. You will find when flow will come to this point. After that it will come to the channel, come to the pipe, and it will inundate the things. Okay, here you can see the depth approx this much. Here the depth is 2.23. Okay, initially depth is 0.61. You will see depth is increasing gradually because flow is coming from this direction. Flow is coming from this direction. Okay, flow is coming from this direction, and you will find the things. So by this you will find a pipe is working and pipe is flowing the water from here to the river. So this is the way you can apply the pipes and everything. And if you have any query, you can comment. I will explain the things in later videos, and I will reply in the comment as well. Thank you for today, and that's it for my side.